Welcome to our first homework in section 0.1. By now you should have reviewed the lecture video 0.0, which was our logistics, and also 0.1, which got us started in chapter 0. Now, admittedly, there is no chapter 0 in the book, so this is supplemental to the book. And if you don't have your book yet, it allows you to keep up with the course until you get it. But do make sure you order your book because we will be assigning problems out of the book very soon. So let's take a look at this one. The way the homework works is they're first defined in the lectures, and then I get an opportunity to either repeat or redefine the homework in these videos. Along with that, there's going to be hints that you get that always come out about the same time that the videos are assigned, maybe even a little bit before. Then after the homework is due, right after the due date, you will be getting a solution. So that's the only time that you have to be able to work this problem. So let's take a look at homework 0.1. It is worth 10 points. And we're to prove this rather odd looking formula that S3 of n is equal to S1 of n squared. Well, what does that mean? Well, let's first look at a definition of S sub k of n, where k can be any integer at all. So S sub 3 of n, using this formula, would be 1 cubed plus 2 cubed plus 3 cubed plus and so forth until you get to some finite stopping value, which we're calling n. So n is not infinite, n is always finite, but it's arbitrary. It could be any integer at all. Now S sub 1, which we call just S, or Sn in the lecture, is the sum of integers. Why is that? Well, S1 of n is 1 to the first power plus 2 to the first power plus up to this arbitrary stopping point n to the first power, which is the same thing as just saying 1 plus 2 plus 3 up to n. So that's the homework problem. So let's get started on solving it. We're only going to cover some hints to get you off on the right track. The lecture gave you two ways to prove a formula for S1, and we are only going to use one of those two methods, and that's the method by induction. So we are trying to prove this relationship. This was S3 of n, and this is S1 of n squared. But really, that seems like a very unlikely formula. I mean, just look at that. There's no cube terms on the right, and there's only cube terms on the left. There's a ton of interactions going. When you square this out, you're going to get a 1 times 2 and a 1 times 3 and a 2 times 3. And the higher the number of integers you do, the more complicated this is going to be. So I don't know. This seems kind of like hard to buy, but let's just check it for n equals 1. For n equals 1, the left and right are easy. All you have is 1 cubed on the left. And if n is 1 on the right, you have 1 squared. Okay, you got lucky. 1 cubed equals 1 squared. But what if n were 2? So 1 cubed plus 2 cubed. Well, 2 cubed is 2 times 2 times 2 is 8. So 1 plus 8 is 9. And 1 plus 2 is 3. Square it, and you get 9. Oh, well, look at that. It worked again. So the question is, would it work in general? Now, we've really done part 1 of the inductive logic, where you set the parameter to a very small value, and you show that it works for that very small value. But now we have to use the rest of the induction, which you're going to do in your homework, and say, well, I need to display that it works for n equals 1. So I am expecting you to put that on your paper when you turn it in. But then you say, well, what if n was equal to some integer m minus 1? N can be anything, so it can be equal to m minus 1. And I will assume that my relationship works for m minus 1. Now, will that necessarily imply that it also will work when n equals m? So that's going to be your job. Use the inductive approach and get a formula for S1, which is in the lecture notes. We previously called it S sub n, and I'm going to give it to you here in a moment. In fact, here it is. From that first lecture, we already proved that the sum of integers is 1/2 n times n plus 1. So if you had S1 of m, well, that would be 1/2 m times m plus 1. So you've got that. So really, this relationship, to prove that, all you really need to do is to show that S3 of n is equal to this formula squared. So that would be 1/4 n squared n plus 1 squared. That would be a little easier to do. So do the inductive proof on this relationship and see what you get. We'll see you back in a few days with the solution.